Hello, and welcome back to Educator.com and this series on AP Computer Science. Today's lesson is about lists. Lists are a very useful and easy to use data structure that's provided in the Java programming language. In this lesson, we'll first talk about the concept of a list and how it works. We'll see that the list is implemented as an interface in Java, and we'll talk about what that means. Then we'll look at two implementations of the list interface, one being the ArrayList class and the second being the linked list class. We'll look at a real example of implementing a list in both the ArrayList and the linked list classes, and then we'll briefly talk about some of the trade-offs between the two implementations of list, ArrayList versus linked list. A list is simply a collection of objects. Any type of object can be stored in a list. However, primitive types such as int, boolean, and double are not objects, and therefore they cannot be stored in a list. If you need to store a list of integers, doubles, or booleans, or any of the other primitive types that are not part of the AP subset, Java provides what's known as wrapper classes. And the wrapper classes have a name similar to the name of the primitive type. So the wrapper class for an int is integer with a capital I, wrapper class for double is double with a capital D, and the wrapper class for boolean is boolean with a capital B. Now the wrapper classes integer and double are part of the AP subset. The wrapper class boolean is not, but I did want to mention that there is such a wrapper class in case you have a need to use it in any of your code. So Java provides these to allow you to store numbers or boolean values in a data structure that only accepts objects, such as a list or an array. A list provides a set of methods for storing, accessing, and removing data. Those are the three primary things that we do with a list. And also for determining the number of items that are currently in the list. These methods are all predefined. You don't need to do any work other than simply use them and use them correctly. Lists are implemented in Java through the list interface, which is designated list with a capital E inside angle brackets. And a list E holds objects of type E. E can be, in fact, any object type. You can have a list of predefined objects like strings or the integer wrapper class that I just talked about. You can also create a list of any user-defined objects that you may have in your code. So if you define a class called student, you can add students to a list that you create because they are objects. And any type of object, whether it's predefined or user-defined, can be stored and accessed in a list. Now, because list is an interface, not a class, we cannot directly instantiate a list. You cannot instantiate an interface. You have to have a class that implements that interface. So if you attempt to do this, if you attempt to define a list of strings by putting string inside the angle brackets and call it A, and attempt to call a constructor for a list with the new operator, this would result in an error because list is an interface, it's not a class. So you cannot call new and construct a list directly. Instead, what we need to do is instantiate an object of a class that implements the list interface. And in Java, the standard Java library provides two classes that implement the list E interface. And those are ArrayList and linked list. If you have a need for some custom implementation of a list, you can simply create your own class that implements the list E interface. And as long as you correctly implement the interface, which is to say you need to implement every method that's defined in the interface list, then you can create any class you want that implements a list by implementing the interface. We'll first take a look at the ArrayList class. ArrayList implements the interface list_e. So because ArrayList is a class, we can instantiate an ArrayList. So what we do is we declare an ArrayList, and then we put the type of object that we want to have in the list inside the angle brackets after the keyword ArrayList. We name the variable that we're going to use to access this ArrayList, and then we call new ArrayList with the same type again and the open and close parentheses. Because we're calling a constructor, we need open and close parentheses even though there's no parameters that we're passing. And that will create an ArrayList that contains strings. It initially does not contain any strings, but that is the type of the object that it is set up to contain. And it assigns that to the variable that you listed here, which in this case is A. So we can then access that ArrayList of strings through the variable named A. Behind the scenes, an ArrayList stores its objects in an array. So what the ArrayList does is it declares an array behind the scenes, and that's where it stores the items that you pass to the ArrayList, that you want to put in your ArrayList. You don't have direct access to the array. You don't have a pointer or a name of the array that you can directly access. So instead of accessing objects by using the array syntax, the ArrayList provides its own set of methods. And you must access the items in the ArrayList through the methods that are defined in ArrayList. You cannot access it through the underlying array. The ArrayList automatically handles memory allocation. And this is very convenient when you're storing an unknown number of objects. When you declare an array, you need to provide the number of items or the size of the array sufficient to store the number of items that you're going to want to put in the array. And if you fill up the array, then as we saw in the lesson on arrays, you need to declare a new array, copy all of the items one at a time into the new larger array, because once an array has been created, it cannot be resized. It's immutable. The size is immutable. So the way the ArrayList works is it creates an array of some default initial capacity. So it allocates an array, and when the array fills up, the ArrayList will automatically create a new larger array for you and copy all the data into the new array. So the ArrayList class handles all the memory management for you. You don't ever have to worry about there not being enough room in the array that's behind the scenes that the ArrayList is using. It manages that memory for you, and automatically, without even giving you an indication that it's doing so, it will create a new larger array if you need more storage for your ArrayList. So it's very convenient and easy to use in that respect.